Turing Complete smart contracts have tremendous promise to upgrade our digital experience and will have a dramatic impact on the future of the internet. Hi, and welcome back to What Kind of Internet Do You Want? I'm Amy James, and today we're talking about Turing Complete smart contracts. Last week we talked about the general concept of smart contracts, where the idea came from, what they are, and how a simple scripting version of them can work on a network like Bitcoin. So today we're taking it a step further and talking about Turing Complete smart contracts. Don't mix up Turing completeness with the Turing test. This isn't about AI convincing us it's human, or at least able to exhibit intelligent behavior equivalent to or indistinguishable from that of a human. Turing Complete simply means that the language is general purpose and can be programmed to do any computable function. This type of smart contracts are enabled by networks like Ethereum, EOS, Tron, Tezos, and Cardano. So today we're talking about Turing Complete smart contracts and why they are an important aspect of Web3. But before we start, please hit the like button and subscribe to the channel, and let's get into it. So what are Turing Complete smart contracts? Turing Complete means that a computer program or network can solve any computational problem, no matter how complex, if it has enough time, memory, and the necessary instructions. It means that the program can approximately simulate the computational aspects of any other real-world general-purpose computer language. So to be Turing Complete, a program has to have basic enough functions that it can do anything any other program can do. And most programming languages today are Turing Complete, such as JavaScript, C++, and Python. As we talked about in our last video, Bitcoin is built using a non-Turing Complete scripting language, which makes it extremely safe for running smart contracts. But it also means that it's not as flexible or easy to design for. Ethereum, on the other hand, was designed to use a Turing Complete scripting language invented for that purpose called Solidity. It has the looping and recursive functions that are necessary for the network to support general uses. The goal of this upgrade over Bitcoin's approach was to create a decentralized world computer that could run applications without the risk of server downtime or honeypot attacks, where the central server containing all of the user data for an application is hacked, that we see so frequently in Web 2. The main advantages of Turing Complete smart contracts is that they allow for increased functionality. By using a scripting language that includes looping and recursive functions, it's possible to build more complex contracts that replicate applications that have typically been centralized, such as crowdfunding, exchanges, and NFT marketplaces. For some developers, the promise of Turing Complete smart contracts powered by a decentralized network is one of the most exciting aspects of Web3. For the Ethereum network, this has been dubbed the Ethereum virtual machine, but the general concept, whether it's on Ethereum, Tron, or Cardano, is that rather than processing at a centralized data center or locally on a personal computer, a smart contract can be processed by a decentralized network of participants. And as we've talked about, smart contracts are self-executing. So once the conditions are met, they can be carried out by the decentralized network automatically without the need for any additional input. And because they are transparent, anyone can either verify what should happen or audit what happened on the blockchain. And this combination of features, self-executing and transparent, means they have the potential to be faster and more cost-effective than traditional contracts or apps. But for all of the promise offered by Turing Complete smart contracts, they also have vulnerabilities, such as issues with looping, blockchain bloat, and the level of trust in information from oracles that are still being worked out. For example, a poorly written looping function could potentially stall the entire network or even cause it to crash permanently. This is what happened in the infamous DAO hack, where a code issue led to the theft of 3.6 million Ether, which was worth $50 million at the time. And because a part of how these networks typically work is that smart contracts are stored forever on a blockchain, bloat can become an issue as old contracts that will never be used again accumulate and increase storage costs for miners. A side effect of putting self-executing code into a persistent database like a blockchain is that they cannot be upgraded once they are deployed. So this means that if there are any mistakes or vulnerabilities in the contract code, they cannot be fixed. And as blockchain bloat grows, it will limit the number of miners who are able to maintain a full node, since it requires a certain amount of hard drive space, despite the processing needs for proof-of-stake blockchains being relatively low. Another issue with storing smart contracts on blockchain is when the contract incentivizes competitive adoption, similar to what happens with concert ticket sales. When a contract for something like a game or financial service that incentivizes the first to purchase is introduced, the rush of new users can cause the same effect on the network as denial of service attack. But instead of maliciously spamming the network like a DDoS attack, they are repeatedly trying to buy something or to execute some kind of function. We saw this happen when CryptoKitties first gained mainstream popularity. It drew a lot of attention and new interest to Ethereum, but a side effect of its popularity was the strain it put on the network, causing higher transaction fees, slower confirmations, and it even caused the cost of running other Dapps on Ethereum to go up temporarily. And while I mentioned transparency as a benefit because the contract is on the blockchain, so it's available for anyone to verify it, most smart contracts are not human readable in a way that most humans who use them could read the code that's being executed. So the danger is that malicious actors could create contracts with hidden code that could harm users. But this is fairly easily mitigated by proxying trust to someone you know that has the skills to audit the code. Probably the biggest potential risk with smart contracts is in order for them to be capable of lots of kinds of functions, they need to be able to access data from the real world. This introduces a dependence on something known as oracles. Oracles can be used for a wide range of purposes, such as providing asset prices for finance, weather information for insurance, randomness for gaming, IoT sensor data for supply chain management, and ID verification for government applications. Their job is to provide blockchains with access to data from outside the blockchain in a way that the contracts can understand and rely on. But oracles have weaknesses that, if exploited, can result in the data that they provide being inaccurate or unavailable. How trustworthy and reliable an oracle is depends on the kind of information it provides, how it receives or accesses the information, how the information is verified, and how the oracle itself functions. To illustrate some of the issues with oracles, let's imagine a scenario where a smart contract is used to determine the receipt of an online shopping order and release the funds being held in escrow to a seller. An oracle could be used to pull tracking data from the tracking website of the courier. So let's say Alice orders a pair of alpaca wool socks from Bob by putting funds into a smart contract. Bob sees the order and ships a box to Alice, and once the oracle sees the box as delivered, releases the funds to Bob. The issue is that the oracle can only know that the box arrived, not what is inside the box. If Bob sent a box full of rocks instead of the socks she ordered, it can't be verified by the shipping data oracle. Oracles also have the same kind of vulnerabilities as other centralized infrastructure, such as DDoS and man-in-the-middle attacks, but these issues can be overcome if the oracle is maintained by a decentralized network with multiple data sources that transmits data through multiple nodes. Turing Complete smart contracts have tremendous promise to upgrade our digital experience and will have a dramatic impact on the future of the internet. But it's still early days. There is lots of experimentation and problem solving that still needs to happen. At this early stage, it's important for users to be cautious and understand the risks if they use a smart contract enabled app, and for governments to provide a regulatory landscape that allows for the experimentation necessary to refine this technology. And that's it for today. If you are excited about the impact smart contracts will have on the future of the web, please hit the like button, subscribe to the channel, and share the video. You can find me at Amy of Alexandria and follow the organization at Web3WG. Thanks for watching, and I'll see you next time.